Alrighty, so what we have been working on is unit rates, and so this is going to be unit rates from tables. That's what we're going to be talking about today. So recall, what does it mean for a relationship to be proportional? So if it's proportional, that means that we have a certain rate of change, that for every X thing I do, that has the same effect on the Y. So when something is proportional, there is a constant change. And that means the unit rate also has the name, the constant of proportionality. Now, this is true for proportional relationships only. So I'm only going to find that unit rate if I have a proportional relationship. So our first one here, we have a table, and we have Ronaldo planning to drive from New York to San Francisco in his car. And Ronaldo started to fill out the table below, showing how far miles he can travel for each gallon of gas he uses. And this is, going to become important when he's looking at how much money he's going to be spending on gasoline and things like that. So based on the table, how many miles per gallon, so the unit rate, did Ronaldo's car get? And they want us to do miles per gallon. So they actually want us to do miles per gallon. That means the miles go on the top. The gallon is basically like the fraction bar, if you want to think of that, or the division sign. And then gallons go on the bottom. So miles per gallon. Now you notice that our table is actually flip-flopped here. This would be the X if we were looking at a graph, and this would be considered the Y. And when we find that constant of proportionality, we're going to do Y divided by X. So we're actually going to flip that. So to find the ratio of each Y value, miles, to its corresponding X value in gallons. So if I can go 56 miles on 2 gallons of gas, that means I would do 56 divided by 2, which is 25 plus 3, which is 28 miles per 1 gallon. So 28 miles per 1 gallon. The next one on my table there is 112 miles on 4 gallons of gas. And when I do 112 divided by 4, I get 28 miles per gallon again. The next one would be, we could skip one. We could say, oh, guess what? This is really easy to divide because 280 divided by 10, the zeros cancel out and I get 28 miles per gallon. And if I do have a unit rate, if it is proportional relationship, then we should have the same unit rate for all those. So if the unit rate is the same for all points, then the the relationship is proportional. So that means that it's proportional. Now my constant of proportionality, otherwise known as the unit rate, is going to be 28 miles per gallon of gas. So is this a proportional relationship? Yes, it is. On our next one, we have Jared taking a trip with his family, and the chart below shows the number of hours he traveled and the number of miles traveled. So once again, remember, this is our X, this is our Y, but when we do this, we're going to go Y and X. So the number of hours is 1, and 1 hour, he goes 40 miles. Well, this chart is wonderful because right away, if we have a unit rate, if we find out that this is proportional, there it is right there. On the next one, we've gotten 10 hours. And go 400. So we had 40 divided by 1. So 40 miles. And 1 hour gave us 40 miles per hour. And then we're going to have 400 divided by 10, which is also 40 miles per hour. The last one we have to check is when they go 1,200 miles in 30 hours. Wow, that is a lot of driving. When I do that dividing, I still get 40 miles per hour. So the constant proportionality is actually right there in our table. So if I have a 1 right here with my x value, that means the y value is my constant proportionality. And it's 40 miles per hour. And since they were all the same, then yes, it is proportional. On this next one, Ariana is making a batch of cookies for her classmates. The table below shows the number of flour and the amount of flour and sugar she needs as she makes more batches. Find the unit rate for the amount of flour she needs per cup of sugar. So once again, think of this as our x and our y, and we want the unit rate to be flour to sugar. So we're going to go flour to sugar. So flour to sugar. And you're like, oh, wait a minute. When we were doing those other ones, I had a bigger number first, and when I did my division, I got a whole number as an answer. So since my larger number, or the number with the larger absolute value, is second, that means when I do my division, I'm going to get a fraction. So that's going to be 1/4 cup of flour for every cup of sugar. So that means that if I had one more box here, when my x is 1, my y, my flour, has to be less than 1. So if this unit rate holds up when we check them all out, that would be the case. So I'm going to be doing 1½ divided by 6, and I'm going to be doing 1 divided by 4. Now 1 divided by 4, we can just leave that, and we actually see that that works out. When I do 1½ divided by 6, I'm actually going to multiply these both by 2, because that will get me 3/12. 3/12 is equivalent to 1½ divided by 6. And then I can go reduce that down, and I do indeed get 1/4 again. So my constant of proportionality is 1/4, and it is proportional because all of those ended up being 1/4. So this one says the table shows proportional relationship, so we know that it's proportional. They are already telling us this. They're saying, look, it is showing a proportional relationship. What is the constant of proportionality? So I'm just going to do my unit rate. So I'm going to do a y divided by an x. Since they're telling me that it's proportional, then I already know that I can use anything on that table. So I can pick any of them and then do that division problem. Now I could pick that one. I could have also picked 2.5 divided by 4. Once again, make these into equivalents that have whole numbers. That's one way to do it. Or I can try to do 1.25 divided by 2. I can do long division to do that. That's up to you. I know this is a fourth, so I know I could multiply it by 4. And that would give me 5/8. And if I do that down here as well, if I multiply that by 2, I'd get 5/8 as well. So my constant of proportionality is 5/8. Now when I want to go write an equation for a proportional relationship, I need to first identify that constant of proportionality, also known as the unit rate, and I'm going to put it in the form y equals k times x. So that k, that is, that's where that goes. That's where that unit rate goes in. So why does it make sense to set up our equations this way? Well, in order to find k, or the constant of proportionality, I do y divided by x. So say I took my original equation here and I substituted in the y over x for the k. These are next to each other. That means I'm multiplying. So that means, so when I do that, I can then write it as y over x times x over 1. Those x's are going to cancel out, and I get y is equal to y, which is a true statement. So that means our equation is nice and balanced. So let's try this down here. We're going to find the constant of proportionality, or the unit rate, however you want to term it. And we do that by saying y divided by x. I'm just going to pick this one right here, and I'll do 12 divided by 6, which is 2. So if my constant of proportionality is 2, and I say that y equals k times x, this is what I'm going to take out. So that means I could plug in any of my x's for here, and it would spit out my y term. So if you remember the in-out boxes, that's what those are like. Next one over here, I'm going to do, this is my x and this is my y. They've just used different letters. So I'm going to do 8 divided by 2, and I get my constant of proportionality as 4. So my equation would be y equals 4 times x. This one down here, I'm going to do 10 divided by 2, which is negative 5, 0 divided by 0, which is 0, negative 10 divided by 2, which is negative 5, and negative 20 divided by 4, which is also negative 5. And when you look at that, you're like, but Mrs. Williams, one of those is a 0. Well, that's okay, because if it's a proportional relationship, it has to go through the origin, which is at 0, 0. So I just found that 10 divided by negative 2 was negative 5. So my equation is going to be y equals negative 5 times x. Over here, remember, this is just different letters that they've used. So I'm going to do 5 divided by 1, which is 5, and my equation is y equals 5x. Down here, I'm going to pause it, and then I want you to pause it as well and try these two, see if you can get them, and then turn it back on. All right, so go ahead and once you've turned this back on, pause it and check your answers in your work to see if your work matches up with mine. Our last one down here, we've got a practice test example, if I can fit it all in there. We've got lots of parts going on here. So this is the minutes, and then I have different machines that I'm comparing. So when it does, it says write an equation that can be used to find y, the number of parts produced in x minutes. So this is my x. These are all different y's. And so I'm seeing, is this a proportional relationship? Is this a proportional relationship? Is this a proportional relationship? So for Q, I get 9 divided by 1, which is 9, 18 divided by 3, which is 6, and 27 divided by 9, which is 3. So since these change, then this one is not proportional. When I do R, I'm going to do 8 divided by 1, 24 divided by 3, and 72 divided by 9. Those all have an answer of 8, so this one is proportional. For machine S, I have 6 divided by 1, 18 divided by 3, and 52 divided by 9. This one is not going to be 6. This one's going to be 5 and 7/9. So this one is also not proportional. So the only one that's a proportional relationship is R. And then it says it wants us to write an equation. So it said only one of the machines produces parts at a constant rate. And then we're going to write an equation for that. So I have my y and my x, and then we know what we found for our constant or unit rate was 8. Feel free to go back and re-watch this video in part or whole and practice some of them or ask any questions that you have.